Hello everyone, in this video I want to explain about the recursion. What do you mean by the recursion? In C language, recursion is generally called as a function call itself is called as a recursion. We know a function call. Function calls are created by call by value and call by reference. So they are general calls. So a function is calling another function, and another function is calling the one more function. Like the functions are calling for another function for a particular task. Then that is called as a normal function call. But this is a recursive call. A function, it is calling to the not another function, it is calling itself. It is called as a recursion. So I want to explain with you a small program that is a multiplication table. Printing of a one multiplication table by using a recursion. So now first time let us start with the main program. So here there is a main. So from this main we are declaring something in comma m variable. Now scanf we are passing taking input of percentage d for n and percentage d for m. Multiplier and multiplicand. So address of m and address of m. After entering these two values, I'm calling as a multiplication function. Multiplication of multiplier and multiplicand. Multiplication value. So n comma m. Example, what you see, better instead of reading the value of m is should be start from 1 onwards. 2 into 1, 2 into 2, 2 into 3 like that. So initial value of m is equal to 1. Okay. So here I am passing m directly, but I take a n from scanf. If your example number is some 2, now 2 multiplication will be print. Now after calling this function, now control transfer to the definition of a multiplication table of functions, multiplication function. Somewhere we have here. The call is created to here. Now here I am writing after the main we have a one more function. The one more function is a multiplication function. So there are two actual parameters are passed from here. The two one is a multiplicand, one more is a multiplier. So now I'm starting here. So it is a void multiplication of two formal parameters I create. So that are integer. Let us take name like a some n. No, you can also create a same kind of name. If you are confusing the same kind of name, let us take something like a x name, x comma, now int I, like that you take. Okay, so now two parameters. Actually, what is our condition? We want to see that the multiplication should be performed, but I should not exceed the 10. We want to print a multiplication table 2 into 1, 2 into 2, up to the 2 into 10 only. So if any case, if I is equals to I is greater than 10. If it is greater than 10 value, it should be we should stop the multiplication process. So that here I should include the base case and recursive case. Base case nothing but the condition will stop. Somewhere we need to stop the recursion. If you don't stop the recursion or calling a function itself, which recursively perform the same task for infinite number of times. Somewhere we need to stop the recursion. Somewhere we need to stop the iteration. You are roaming some surrounding of a one tree. You're continuously roaming. So in case your number of rounds are 10, then you after the 10 rounds you need to stop. You should not continue for the 11, 12 up to the infinite number of times. Somewhere we need to stop the calling itself of a function. So that here we are taking a base case. If your multiplication is up to 10, we need to stop. So that I am return nothing. So if it is greater than, we should stop the process. So that like that I should use this condition. Next, actual return function, actual recursion process we want to start here. What actually we want to do? We want to printf every time percentile d slash n, comma, we want to multiply the x into that x into. So instead of the x, we let us take some p variable. Now we want to see now p into that I, that I. Okay. So I should also increment. You can increment here, else you can increment after this statement. Okay. So then after increment the I value should be increment every time. Okay. After incrementing, I'm calling the same function once again. I'm calling same function. That is again multiplication function with new parameters. With new parameters. What are that? There is no change of p-value. There is no change of the p-value. P-value initially what we have received from the calling function, the same value we want to continue. But I value will modify because from this statement I value will be modified, increment. So that we want to send this form actual parameter I. I'm calling the multiplication function once again. I will explain the procedure step by step. Here what happened? So this is the normal function, main function. It is a calling function. From this, we are passing two parameter. One is a multiplication, one more is a multiplier. Initially, m value is a 1, n value is that you are selected number, n comma m. So we are passing. So now they are actual parameters. They transfer to the corresponding called function. Okay. Now void mul is the definition of a function. There are two parameters are there. One is 2, one more is a I. Okay, we want to change the I value, but we don't want to change the P value. So P value initially, which is passing from the end, that n is equals to 2. Now 2 only will be written until completion of your program. Now I value initially 1 because m value is 1, so I value is a 1. So now what are my initial parameter to the multiplication function? One is a 2 comma 1. Now, but we want to verify the base condition. Base condition finally should stop the iterations, number of the iterations. Initially, obviously, what is the initial value of I? One only. One only. We started from your first round. You started with your first round. So it is obviously not greater than 10. It's obviously not greater than 10. So condition will not execute the return value. Condition will false and control enter into the printf statement. What is my initial multiplication? What is my initial value of P? P value is equal to 2. So in the first iteration, what happened? P value 2, which multiply with 1. So this is the first iteration. So I can say it is a iteration number 1. Whenever there is a iteration number 1, what happened? 2 into 1 multiplied. Now followed by I will be incrementing. In this case, what happened? I incremented. I value incremented. Okay. I value incremented because after this statement we have a I increment. I value incremented. So this is a I, this is a M, this is a P. Now after this statement, again we are calling same function. We are calling same function. Same function. So control will call the same function. Again, it is calling to the same function. But there we may see some changes in the parameters. What is my p value? We didn't apply any changes in the p value. P value still 2 is true, but I value has been changed. I value incremented. So after increment, it is become 2. Now in the second iteration, whenever we call a multiplication function second time, the I value will become 2. Now what are the new parameters? It is become 2 and this is also will become 2. Now 2 comma 2 are become a parameters. Now we are verifying the condition. Is that 2 is greater than 10? Not. It is not greater than 10. So condition fail. Control will not execute the return value. So control again enter into the printf statement. This time what is the multiplication value? 2 into 2 will be multiplied. So the multiplication will become 2 into 2. In the second iteration, multiplication will become a 2 into 2 multiplication. Okay. So this is the second. Now after printing the this multiplication result, control again enter into control. What is the next statement? I place place. So I again will be increment. This time I will become 3. In the next iteration, before entering into the next call after multiplication, I value been changed to 3. Okay. Now, what is the next statement? Again, we are calling a multiplication function. Same function will be called because who is calling multiplication only calling. Calling function is multiplication. Who called again multiplication function itself called. But whenever it is calling new time, next iteration or next time, the I value been changing. So now what is I value? Now this time I value is become 3. Now what are the new parameters? 2 comma 3 will be passed to here. Now here the value is become 3. This is will become 3. The new updated values are 2 on the I value 3. P itself it is 2 itself. Now is that 3 is a greater than 10? Not greater than 10. Condition false. It is not greater than, until it is not greater than 10, we cannot enter into the return statement. We cannot execute the return statement. So control will pass to the again directly printf statement. Now printf will execute the P into I. P into I will execute. So this time 2 into 3 will be multiplied. So generally this is called as a recursive call. So the function, because in this corresponding function we have a base code for multiplication. We are not creating a one more multiplication function to execute the corresponding base code or whatever the corresponding multiplication code. We are reusing the same multiplication function several number of times until the condition is false. After multiplication of 2 into 3, again I will be increment. So this time I value will become 4. I value will become 4. Whenever we are calling one more time the same multiplication function, the new parameters are will become 2 comma 4 this time. So 2 comma 4 will be multiplied. Like that, which can be called for several number of times until we reach the 2 into 10. Until we reach the 2 into 10. Okay. So whenever after 2 into 10, in will be increment. This time I value will become 11. Okay. So next I value will become 11. Obviously, the parameter input value will become here 11. So whenever it is become 11, I is greater than 10. Yes, true. So whenever it is after the 10th number call of a multiplication, I value will become 11. So 11 is greater than 10, it is true. Then that time control will enter into the if block. If block directly return nothing. Return nothing. So it is function is returning without passing any value. So function will exit from the calling function, exit from the corresponding block. Now actually where the initial call is created from multiplication. So now control will transfer to the corresponding main function. So now from we want to close the block. So we want to close the corresponding main block. That's it. See, how many lines are there in the main function? There are only three lines are there. One is to declare the variable. One line is for to read the input value. One more line to pass the parameter. Oh, call a function with passing of two parameters and comma m. Now control transfer to the corresponding definition part. Now here the same logic executed in this corresponding block, but the multiple times calls are created. So function is calling itself for until condition is false until particular iteration we are running the multiplication. So if you not stop by using this condition, if you not stop by using the condition, the control will execute continuously. Continuously, the compiler execute the same function calling itself for infinite number of times. So to stop somewhere, you should apply some condition. The condition is called as a base case. The condition is called as a base case. The remaining part of the code is called as a recursive case. So this is for a simple program multiplication table. The same way, we can also perform for sum of n natural numbers. Sum of n natural numbers. Very simple code. So next, let us call for sum of n natural numbers. So here I want to declare something like a variable p. Okay. So if p is equals to 10, what is the program name? Program name is a sum of n natural numbers. This is the next program. So now here I'm writing the int p. So now followed by I'm calling some function. Okay, some function initial parameter is p itself. So for that I should read the some read the value. So now I'm calling some function with here this p value as a parameter. Okay. Now control transfer to the sum definition. Here we have a sum definition. So let us write sum. Okay. So up to where the sum should be done. Actually, before go to that, you should understand how the what is the sum of a natural number. So in case if your enter value is a 5, then summation should be 5 plus 3 plus sorry 4 plus 3 plus 2 plus 1. This is sum of a natural number. If you are enter something like a 4, then what are the sum of a natural number? 4 plus 3 plus 2 plus 1. sum of a natural number. So we need to satisfy this corresponding code by using the sum function. So it is a void sum. To catch your initial number, here I am declaring one formal variable int n, int n. Our condition should be somewhere we should stop the recursion, so that I am taking a base case. If you not stop, obviously, if you go to the some for loop, we can run all for loop related codes by using the recursive calls or even while loop also. For loop, while loop, we have a one condition to stop the iteration. Similarly, it is also recursion. Calling itself, it's like a iterative statements. Somewhere the iteration should be stopped so that we should add a one condition. Uh, the condition is available from the base case. What is our base case for this corresponding in sum of a natural number? You can sum from 5, 4, 3, 2, 1. But if you not sum 0, -1, -2, like that, not increment more than 1. Okay. If that corresponding is less than 1, we could say it's less than 1. In case you can create your own condition. If it is less than, okay, 1 up to 1 it is okay. If it is less than 1, then we want to write return. So I'm not returning anything, I'm return nothing means it's for the void case. In other case, want to perform sum of natural numbers. In another case, we want to do a return. You can keep in a else case. Otherwise, you can keep in a else case. In else case, we are returning sum of your first digit, sorry, first number plus followed by, first I want to elaborate, let me write sum of n minus 1. You can write the same code in several ways. You can write this expression at the part of return, or else write separately and return some result. In that case, let us keep here. If you keep something executing by using the return, it will be an integer type. Uh, so here also it should be able to access the value. So here I am taking with a return. So what is going to be happen? Whenever if we call uh, 5 factor of a natural number, 5 plus 4 plus 3 plus 1. 4 is this one. Then 3, whenever your number is 3, then 3 plus 2 plus 1. Whenever it is a 2, then what happened? 2 plus 1, like that. So I could write, if your number is 5, the 5 result, it is become sum of 4 natural number. So I could write here 4. Means I can write n minus 1. N minus 1 nothing but 5 minus 1. Okay, like that I am writing here 4. So what happened here? This is n plus sum of, I can write 4 nothing but n minus 1. Okay, 5 plus 4 sum of n natural numbers. Then next followed by, already the 5 is under process. Next I want to process n minus 1 plus next sum of n minus 1 minus 1. N minus 1 minus 1. So means it is a n minus 2. It means n minus 2. So like that, what happened here? So value is, it is a 5. It is 4. N minus 1 nothing 4. Sum of n minus 2 means it is become a 3. It is followed by 3. Next we want to add sum of n minus 3. It become 2. So like that, we are calling some function for every time. In every iteration we are adding. So I started some function calling by here. Okay. Next year, when I am calling some function in every iteration, in the meanwhile, one natural number is get adding with the result. Okay. Next, what happened? 5 place, 4 place, 3 place, 2 place, sum of that n minus 4. So like that, we are adding in every calling of a sum function. For every successive of calling of a one sum function, we are adding result to it. In such a way, finally we reach up to 2 plus 1. Whenever it is reached to the 1, condition will fail, control will return. So this is the process we are doing whenever we are in the return. Whenever you call a some recursive call from the return, the logic will be changed whenever you want to execute in a normal block. But unfortunately, I choose a return. Immediately, I change the return value also, return type of a corresponding some function. So the same recursive function you can execute in a normal block. You can also call a recursive function by using the by at the statement of return. There are two ways we can do this one. Okay. So here what happened in such a way? Let us evaluate the process. Now for function is calling to here. I just want to be changing here. There is a one more variable. There is a one more variable because I am processing with return value so that it should be declared with one more variable, something like a q. Something like a q. Now this q is equals to sum of. Finally, we want to printf percentile d comma. So this is the program at main. Now here what happened? So some function is calling me your n input value, your n input value. So initial call. This is nothing but initial call. So what is your input if your n value is equals to 5? If your p value is 5, then n value will become 5. Is that n value is a less than 1? It is not less than 1. It is obviously a greater than 1. So condition cannot execute this. Now control enter into the else block. Okay, now else block directly we have created a state only single statement, that is a return statement. At the place of return expression, we have included a function call. Now what is the n initially? What is your n? N is 5. Like this. N is 5. Place I'm calling next one n sum of n minus 1. Sum of n minus 1 nothing but which calls the sum of 4 in the first iteration. Sum of n minus nothing but 4. Sum of 4 is called. Okay. Still, we are not exit from the block. Exit from the block. We are hold the value of 5, and meanwhile we are calling sum of 4. Now this 4 will return to here in the next call. So what happened here? What is the value of n now? This time it is become 4. Okay. So 4 greater than 1. So condition false. So control again enter into the else block. Already we are hold the value of 5 and we have called the 4. Now what happened here? Already 5 is there. Okay. This time 5 is there. Now what is the written expression? Again n plus n minus 1. What is the new n value? New n value 4. So new n value will become 4. Again we are calling sum. This is the expression for complete a first call. Any one of the call. That expression is common for every call. So in this call what happened? N is 4. N minus 1 nothing but so n minus 1 nothing but 3 this time. So I could write sum of 3 will be called. Whenever you call it sum of 3, This statement is common for sum of 3. This statement is common for sum of 2. This statement is common for sum of 1, sum of 5, sum of for every call. This statement is common. So meanwhile, we are preserving the previous value because our call is not returning any values. Still, it is calling itself. We are in the same block of the code. So now again we are calling with 3. Whenever it is 3, this statement is common. Now what happened here? N value is 3. N value is 3. Next sum of n minus 1 nothing but 2. So this 3 still it is there. So already previous 5 is there. And next 4 already there. 5 plus 4 already it is become 9. Plus now we are calling with 3. But whenever it is 3, this statement is common. N minus. What is the n value in the current iteration? It is become 3. Now sum of n minus 1 nothing but it is become plus sum of 2. N minus 2 will be called. So what is the value of 5 plus 4 plus 3? So it is become a 13. 12. Plus again we are calling sum of 2. Sum of 2. Now what is the new n value? New n value is become a 2. Okay, is that 2 is less than 1? No, it is not less than 1. Condition false. Now again control enter into the same else block. Again for the 2, what is the n value now? In the current n value is become a 2. So 2 plus 2 minus 1 this time. 2 plus 2 minus 1. So we can write 2 plus already it is 12. 12 plus now what is the expression for every call? N plus 1. What is the n value now? 2. N minus 1 nothing but sum of 1. Sum of 1. Now it is become 14. Sum of 1 will return the 1 plus sum of 0. Whenever sum of 0, the condition will become false. Condition will become false and control return to the corresponding call. Okay, so nothing but this block will stop the process. Final result will return to the condition. Will return. What is the final value? 14 plus 1 plus 15 value will be written as a true case. The true case which will transfer and assign to the Q value. So this is a one more kind of recursion process by implementing in a the at a written value. So like that we have a Fibonacci series and factorial of a given number. We'll discuss the same concept by using the two programs.